Hi guys, this is Mr. Urrego. Welcome back to our practice review for the Algebra 1 Florida end of course exam. Okay, so that's right. Right now we're practicing for the end of course exam. The Algebra 1 is a mandatory test that you have to pass in order for you to graduate here in Florida. So guys, we have to pass this. Please check the description below. You'll have material. I have done more videos. I did the Beat the Test series for this Algebra 1 end of course exam practice. So I'm putting a lot of material. So just please check the description. Also, I'm putting links for all the material and all the websites that I'm using in this series. First of all, let me show you. Right now I'm here, fsaassessment.org. So that's the website. Okay, this is for anybody that wants to practice this. From here, what I'm going to do is I'm going to go to the right side and hit practice test. Okay, again, there's more material here. Just check this out. But I'm going to go straight to computer-based practice test. I will also do a series of videos about the paper-based practice test. I will do that series again. That's the next series after this one. Today we're doing the computer-based practice assessment materials. Again, take the computer-based. We're taking this out. Anybody can do this, so make sure you practice this before the real end of course exam. Here you need to sign in. Alright, this is open for all Florida students and I believe some other states, I don't know, Missouri, Alabama, Georgia, I don't know, there's other states that are able to do this. Please check your state. The Algebra 1 is for 7th and 8th graders. Alright, so I just hit 8th grade. And underneath I will have the Algebra 1 EOC practice and I also have the geometry. Check out my series also about the geometry and of course exam, just in case you haven't passed that either. Today we're doing the Algebra 1 and of course exam. Check this out, change the anything that you want to check in this thing. I'm going to go straight to the test, begin test 10 now. And now I'm going to get into practice test, computer-based practice test. Alright, I suggest for anybody and everyone that will take the Algebra 1 EOC to do this. Make sure you do. Alright, first question. We'll practice how to input the questions and all that stuff. Alright, let me get a pencil here real quick, pencil. A study estimates that cost of tuition at the university will increase by 2.8% each year. The cost of tuition at the university in 2015 was this, $33,000. The function b of x modeled the estimated tuition cost where x is the number of years since 2015. Click on the blank to enter an expression that completes the function b of x. Okay, so let's think about this. In 2015, the cost was $33,741. Each year, the tuition will go 2.8%. So in 2016, this is going to go 2,008%. Whatever they get the following year, it will increase the same amount. Okay? So this is a growth function. This is a growth function. Alright? Let me explain about the growth function. So like I said, this is going to be a growth function. It's an exponential function. How come? Because they're saying that the tuition, the whole value increases 2.8%. So this is not linear. This is not the slope. Oh, it's going to increase $2,000 per year. Oh, it's going to increase $500 per year. No, it's going to increase 2.8% of the whole thing. So this is a growth, okay, function, exponential function. B of x is the tuition where x is the number of years. Normally we use t as years, but they're using x. Alright, so my function is a is the initial amount. 1 is 100% plus the rate. This r is going to be in decimal. The r, this is the r. But right now I have as a percentage. I need this as a decimal, which means I have to divide that number by 100, and that's going to give me a decimal. It's going to be a percentage as a decimal, and that's going to be equal to 0.028. Alright, so my a is the initial amount. What's the initial amount? The 33,741. So my function b of x is the same as a, which is 33,741. In parentheses, 1 means the 100%. R is the increment, the growth, 2.8% as a decimal, 0.028. Everything to the t power, which is the time. But in this case, the time is given by nx. Those are the numbers of years. So let me finish. B of x equals 33,741. 1 plus this is going to give me 1.02x to the x power. And this is the growth function. The inside is called the growth factor. All right, that 1.028. They're asking, oh, what's the growth factor? Growth factor is 1.028. All right, so let's keep that in. I need to use this, that, oops, okay. So let me scroll up or down. Let's see if I can scroll up. Here we go. I need this function, the 33,741. So b of x, 33,741. Okay. Parenthesis 1.028. Where's the parenthesis? Open the parenthesis. 1.028 close parenthesis. Oh, it opened again. Where's the back button? Back button is here. Okay. To the, how do I put an exponent? Where's my exponent? Here we go. Let me stop for a second. So when I'm using this calculator, okay, you see here I have a box. Let me erase this a little bit because I know what my function is already. I know it's going to be, let me write it down on the top. Okay, something that I missed is that this is a program that you use to input equations. Okay, so I forgot. Because right now the only one that has an exponent is this one. Alright, so that one is an exponent, and you notice it went to the top. And now I'm going to put my variable right there. So it's 33,741, parenthesis 1.028 to the x power. That x is an exponent. Make sure. Alright, make sure you practice with this. Alright, and that's my answer. Here we go. Next question. Jeremy determines that square root of 9 is the same as 9 to the 1/2. Part of his work is showing, so now this is his work. By the way, this is a question that is also the beta test. I'll put a link underneath. Which expression or equation should be placed in the blank to correctly complete Jeremy's work? So what's missing here? Alright, so first of all, square root of 9 is 3. That's right. But 3 is the same as 3 to the first power, right? Because there's no exponent, you have a 1. This is right. But 1, I can break it into 1/2 plus 1/2, which is right. Here comes the property. What happens here? What happens? So now, guys, there's one property that is like x to the second power times x to the fifth power. When I have two powers with the same base, I add the exponents, so my answer would be x to the 7th. So same thing as here. I can say, all right, x to the 7 is the same as what? X to the 5th times x to the 2nd. That's what I have here. All right, how am I getting this? By the way, I'm adding the exponents, right? That's the step that I'm missing. X to the 7 is the same as x to the 5 plus 2, right? I'm adding the exponents. That's how you got the 7. All right, here, x to the 7th power is the same as x to the 5 plus 2. Why? Because x to the 5th power times x to the 2nd power. So this is the step that is missing. All right, I have here 1/2 plus 1/2. What happened here? 3 to the 1/2 times 3 to the 1/2. Keep the same base, add the exponents. All right, and from here, because they have the same base, same exponent, I keep the exponent and I multiply 3 times 3, which is 9. If I have the same exponents, I have, 4 to the 1/2 times 5 to the 1/2. This is the same as 20 to the 1/2. That's another property of exponents. If they have the same exponent, you can multiply the bases. All right? If you have the same base, you add the exponents. So what I'm missing here is 3 to the 1/2 times 3 to the 1/2, and now 3 times 3 is 9, and I keep the same exponent. So my step here is 3 to the 1/2 times 3 to the 1/2. There we go. That's what I'm missing. Number C. And I need to click it because if not, it's not going to let me go to the next question. C. All right, let's go to question number 3. Okay, question number 3. Let's read it. The table below shows the values for the function y equals f of x. So this is the values of y equals f of x. Complete the table for the function y equals f of 1/5 of x. All right, let me show you transformations. So this comes from here. Okay, so these are normal transformations. All right, this is a vertical translation. Up is positive, down is negative. If it's inside the parentheses, then it's horizontal translation. If you have a positive, this is to the left. This is a negative, goes to the right. Reflection over the x-axis. If it's inside the parentheses, it's a reflection over the y-axis. Here comes our transformation. If I have a number inside with the x, that's a horizontal, either compression or stretch. Okay? And the reason I'm getting here is because I'm going to show you why it's being transformed. Is it going to transform my y plus d minus d? You see that? Plus d minus d. Is it going to be transform my x value? If it's positive, it's going to go to the left because I'm subtracting. I'm subtracting the x. I'm adding the x. You see that? All right. So this is the easiest way how to solve this thing. So horizontal compression, horizontal stretch. I need to find how much is the value of b. In my case, is 1/5 times x. So b is 1/5. B is 1/5, which means it's between 0 and 1. So I'm going to have a stretch, horizontal stretch, meaning it's going to be some kind of flat. All right. My answer is my regular point xy is going to turn into x over b comma y. That's what I need from here. So here we go. Get a pencil here. And they're saying that my regular point is going to be transformed into x over b comma y. So I have in my table values. I have -4 comma 7 is going to be transformed as -4 over b, but b is 1/5, comma 7. And -4 divided by 1/5 is by doing the reciprocal. When I'm dividing by a fraction, I multiply by the reciprocal, which is 5 over 1. So this is going to be the same as -4 times 5, which is -20, comma 7. And that's my first value. -1. Change the color. So -1, comma -2, this value is going to be transformed as -1 over b, and the y does not change, so the y is -2, stays -2. -1 over 1/5 again is the reciprocal. Let me show you that. So -1 divided by 1/5. Keep, change, flip. Keep, change, flip. -1 times 5 is -5. Alright, that's what I meant. So you multiply by the reciprocal. Reciprocal 1/5 is 5 over 1. Multiply by the reciprocal, -1 times 5 over 1, -1 times 5 is -5. And the y stays the same. So I'm going to do that to every single point. 0, 3 is simple because it's a 0. So 0, 3 is the same as 0 divided by 1/5, 3. Well, 0 divided by a number is 0, so that didn't change. Next value. Let's go back to red. 3 -4. 3 -4 goes as 3 divided by 1/5, -4. 3 reciprocal 1/5 is 3 times 5, which is 15 comma negative 4. Last but not least, blue, I'm going to have 6 comma 5. 6 comma 5 is 6 divided by, remember, 6 divided by b, which is 1/5, comma, is the same value of y. Y does not change, and y is 5. Reciprocal of 1/5 is 5. 6 times 5 is 30 comma 5, and these are my new values. Okay, so that's what I'm looking for. Let's get the mouse over here, and here is going to be negative. So my first value is negative 20. Negative 20 comma 7. My next value is negative 5, negative 2. Negative 5, negative 2. Oops. My next value is 0.3, which didn't change. 0.3. My next value is 15.4. 15, negative 4. The last value is 30, comma 5. If you plot these values, and these values, you'll see that this, let me show you real quick. Let's pretend, I'm not going to plot all this, but let's pretend that this graph is going to be something like this. Let's pretend, okay? This one is a stretch over the x-axis, which means it's going to be something like more flatter, more wider, okay? More wider. That's the idea. All right, so this is your table of values, and this is the rule how to find the values, okay? I hope you took a screenshot of that transformation chart. It's really important. I'm going to put it again. All right, I'll put a link underneath as well. All right, let's keep going. Question number 4. Max collected data on the height of each of his 20 classmates. The box plot shown represents his data. Okay, so this is all the information. Click over the number line to complete the dot plot that could also represent this data. Again, a couple things are really important. First of all, he's saying that it's 20 people. All right, 20 people. Do I have 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I don't have all the data. That means I have to complete this somehow having my box plot. So first of all, I need to understand whether my box plot or my box and whisker plot. This is the minimum value. This is my maximum value. All right. This is my lower quartile or my first quartile. This is my upper quartile or my third quartile. And this is the median. Okay, I can plug it in there. Median. All right. Very important. I think I will do just a video on this, on box plot. Most likely I'll link it underneath. Okay, so that's the information about my box plot. What is all this? First of all, I need to know how many data points I have. They're saying that I have 20. So I'm going to put 20 right here. So I have 20 data points. When my information is organized, it has to go from least to greatest. Organized. I have some of the data already here. I just need to complete the values. So let me see what information do I have. First of all, do I have my maximum value? Here. My maximum value is 76. Do I have it here? No, it's not there. So that's the highest value, so it should be here, 76. Okay, so that's missing here. All right, let me get it here right quick. So that's 20, that's 20, that's 20, that's 76. All right, I need a point right there. Do I have my minimum value, which is, according to this, is 59. 59, do I have it? No, 59. That's my lowest value. So that goes. I'm completing values. All right. Now, let's go with lower, median, upper quartile. The first thing that I need to do is my median. All right, my median. Because I had an even number of data, which is 20, my median is going to be made out of the average of the two middle values, 10 and 11. After 10, before 10, I have 9 values. After 11, I have 9 values. 1, 2, 3, 4, 5, 6, 7, 8, and 9. When I have an even number of data, I take the average or the mean of the first two, or the middle two, and that's going to be my median. But right now, my median according to this is 65, right? Median is 65. Do I have value 65? Yes, look at this. I have two 65s. So this is 65 and this is 65. If I add them divided by 2, it's going to give me 65. All right, remember, it's the average of the mean of those two. So now I got this, 65. Amazing. All right, now let's go to the lower quartile and the upper quartile. My lower quartile is going to be the median of the first half. But because I did the average of these two, technically I didn't use the 10th. This value, I didn't use it. So now this is part of the first half. I got to find the median of the first half. Because the median of the first half, I have 10 values. Again, my median is going to be the average of the middle two values. All right? And which are the middle two values? Between 1 and 10 is going to be 5 and 6. That's going to be the median, the average of those two. And according to this, my lower quartile is 62. 62. So that's going to be 62 and 62. Because again, is the average of those two. But I already have 62. That means 62 and 62 is going to be divided by 2 is going to be 62. So that means I have to add at least another value here in 62. All right, 62 and 62 divided by 2 is going to be 62, to keep it simple. All right, let's go and do the same with the upper quartile. Okay, the upper quartile, again, is from 11 to 20. Therefore, my middle values are going to be 15 and 16, the average of those two. Do I have an upper quartile? Yes, it's 70. Do I have something in 70? Look at that, two 70s. 70 and 70. Added up, divided by 2, 70. No problem, I have that already. So you see I'm filling up those tables. Again, every dot that I have here, it's already in this chart. Okay? What else is missing? Alright, so I have my minimum, my lower quartile, my median, my upper quartile, and my maximum. Let's finish this point. I got 159. I got two 62s. Then here comes 65 and 65. Let's put 65 and 65. Oh, but that's my median. Hold on, I had those two already. That's a mistake. Oops. Alright, that's my median. I have them already. I counted this already. I counted this already. I counted the maximum. What else I counted? Those 70s. I apologize for that. Alright, so this is my median. Oh, that means I have to complete all these values. Okay, excellent. So I have 3 values missing and I have 3 values missing. Alright? Now, these 3 values have to be something between 59 and 62. Again, I'm not doing average, I'm doing just positions. So something between 59 and 62, I can call that, I don't know, whatever my color, I guess. Let's use green, I guess. I can call this 60, I can call this 61, and I can call this 61. So that means I can call that 60, 61, and 61. Something like that. I just need to fill up that. And now these 3 values have to be between 62 and 65. Alright? I can have more 62s, I can have more 65s. I don't want to confuse with them. Let me add anything from 62, 65. So let's do 63. Let's do 163 and 2 64s. Okay? 63, 2 64s. I'm not changing these values at all. Alright, now let's go to the right. I didn't count these 2 values, which are 69s. So 69, 69s. I'm sorry, yeah, 60, no, these are 67s. What am I talking about? 67s. 67, 67, so I can put here a 66. So 2 67s and 1 66. Alright. Now we go to the right of the 70. I didn't count any of these 3. And I have 3 boxes left. That means I have to complete, let me see, what is this? 71, and this is counted, and this is 73 and 74. So this could be an example of the data that is missing. All right, the main idea was to do the median, the lower quartile, the minimum value. This is the upper quartile, and this is the maximum value. All right, that's the main thing. Again, I will put a link underneath to explain how to do the box and whisker plot again. All right, guys, let's go to number 5. So here we go. A bird drops a stick from the top of Miami Tower. The height of the stick after X seconds is given by this. Select all the correct interpretations of the coordinates of the point at the maximum of the function of f of x. So let's read carefully. First of all, they're saying, let's get some red, I guess. First of all, they're saying a bird drops from the top of Miami Tower. So this movement is starting from a tower here in the top. All right, and then the bird dropped the thing. Okay, the height of the stick after X seconds is given by that. So if X is 0, my initial height is 625. So my tower is 625 feet. I think that's the units, right? Okay, I don't see the units, but most likely it's going to be feet. All right, so the bird's right there. Select the correct interpretation of the coordinates of the point at the maximum of the function. The maximum of the function right now is the highest point, which is that, the initial value. All right, so let's understand this. The time it takes the stick to hit the ground. The time when the stick is at its highest point. Yes, that's what the function is. What is my maximum? What is the maximum? Is when the stick is at the highest point. So this is an answer. What is the maximum? The time it takes the stick to hit the ground? No, that's the maximum. Maximum. The height of the stick. So this is my answer, right? The next one, the height of the stick when it's dropped from Miami Tower. The height of the stick. That's the maximum. It's up there. The height, yes. What else? The time when the stick is dropped from the top of Miami Tower. The time when the stick is dropped from the top of Miami Tower. That's where the movement starts. All right? And my X is, the movement is the drop. X is seconds. So the time when the stick is dropped from the top of Miami Tower, yeah, that's where everything starts. The last one is the distance of the stick from Miami Tower when it hits the ground. No. Everything is related to the maximum. And my maximum is not the distance from here to here. My maximum is not the time that it takes to hit the ground. No. My maximum is the time when the stick is at highest point, yes. My maximum is the height itself when it's at the top of the tower. And the maximum is the time when the stick is dropped from the top of the Miami. That's where everything starts. So those three will be my answers. Let's choose and let's go to number 6. 1, 2, and 3. Clear? Go to 6. Excellent. Let's read. Some of the steps in write a solution to this equation are shown below. All right. Select the correct reason for line 4. Oh, the last question. I'll write a solution. Which of these is going to be my answer? All right. So I suggest, guys, this is an equation. Let's solve the equation one step at a time. And then from there, we can tell which one is the right answer. So if I have this equation and I'm going to solve it, which is what I have here, this is the first step, which is given. My next step is every time I have a parenthesis and a number on the outside, I have to distribute. Distribute 2.5 times 625. If I multiply that, let me use over here the calculator. 2.5 times 6.25 is going to give me 15.625 of x. then 2.5 times 0.5, or half of this, is going to give me 1.25 equals to 11. That's the first thing, and that's called the distributive property. Okay, if I have to call this, then I have to move this over here. Oh, it doesn't let me because it's the only question. Alright, so no. So here will be the distributive property. Let's write it down. Distributive property. Okay, which is this question. The next step here, solving the equation, is I gotta solve for x. I have to get rid of that 125 first. It's adding, so I subtract. So my next step will be subtracting minus 125 and minus 125 on both sides. Alright, so I'll have 15,625x equals to 11 minus that. 11 minus 1.25 gives me 9.75. And I just subtracted. Look at this answer. Subtraction, profit, equality. That's right. My last step to find the value of x, I have to divide by 15,625 by 15.625. I'm dividing. And 9 divided by 15.625 gives me 0.625. And my answer is division. Division, division, division. And this is my final answer for line 4. Alright, here we go. Let's look at question number 7. Question number 7. Core is using successive approximations to estimate a positive solution to f of x equals g of x, where f of x is this and g of x is this. The table shows our results for different input values of x. So the whole idea is just using this process, successive approximations, to estimate a positive solution between these two equations, right? Okay, so the idea with successive approximations is to start plugging in values until you reach a value that is close to the answer. That's what they're saying, to estimate a positive solution. So she started with 0, 1, 2, 3, 4, and she went back to 3.5. That means at 4 she went over. Alright? If you notice, at 0, she plugged it into the f of x, you got 13, but g of x got 14. She plugged in 1, 14, 17, 17, 20, then 22 and 23. So f of x is getting closer to g of x. But then when she plugged in 4, she grew from 22 to 29. But g of x, 23 to 26, and it got farther away. Before, the 17 to 20 is 3 away, it's 1 away, but now it's 3 away again. That means my answer is between 3 and 4. So that's why she went back to 3.5. When she went to 3.5, now one answer is 25, and the other one is 25.5. She's getting closer. So they're saying, using that, use Core's process to find the positive solution to the nearest tenth. So what I need to do is just get back to here. I know that she's decreasing now, so let me try 3.4. Pencil, pencil, pencil. Let me try 3.4. So again, what is the process? F of x is equal x squared plus 13. What is she doing? She's replacing the x by all these values. In this case, I'm going to do 3.4, so I'm going to have 3.4 squared plus 13. 3.4 squared plus 13 is going to give me 2456. Alright, 3.4 squared plus 13, I put in the calculator, and it's going to give me 2456. Now I'm going to do the same thing with g of x. G of x is, where is it? 3x plus 14. G of x is 3x plus 14. I'm plugging in 3.4. 3 times 3.4 plus 14. Plug that into a calculator, and that's going to give me 24.2. 24.2. You see that it's getting closer? 24.56, 24.2. Let me try it out the next value, which is 3.3. Successive approximations mean decrease. Successive is one after the other one. Approximations is getting, approximate the values. Change color, so we can have some color code right here. Let's get red. Now let's try 3.3. F of 3.3 is going to give me 3.3 to the second power plus 13. Plug it into the calculator, and it's going to give me 23.89. Interesting. Let's do the same thing here. G of 3.3 is equal to 3 times 3.3 plus 14. Plug into the calculator, and I get 23.9. Okay, let's go back. Use to find the positive solution to the nearest 10th, 1 decimal place. If I round this to 1 decimal place, 89 becomes 0.9. So now my answer, approximate, equal. And what was the value of x? 3.3. So again, Cora is using successive approximations to estimate a positive solution to this, where my f of x is that and g of x. The table shows blah, 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 input values of x. Use Cora to find the positive solution to the nearest 10th. In my case, the x value is 3.3. I'm going to scroll down and input 3.3. 3.3. And that's my answer. Okay, so I'm going to stop here, 36 minutes, and I'm going to go next to question number 8 and finish the whole series. Again, if you're understanding something, guys, if you're learning, please like the video, subscribe to the channel, hit the notification bell so you get notified for the next video and all the other videos. I will go heavy on the Algebra 1 EOC review because we have to pass this test in order to graduate. So it's not an option. We have to pass it. I'm going to do as many problems as I can to review all practice exams that are available for the EOC. All right? Stay tuned for the next video. Take care, guys.